And welcome back. As we continue looking at some deeper programming concepts, let's go ahead and take our first look at something known as the clone method. So the clone method is something that we actually are going to inherit here. So it's actually something we don't have to necessarily write complete from scratch because it's something that's inherited from the class object. The method in the class object has no parameters and is supposed to return a copy of the calling object. However, the inherited version of clone was not to be designed to be used as is. Like you can't just plug it in and say clone. Instead, you're expected to override the definition of clone with a version appropriate for the class that you are defining. The officially sanctioned way to define the method is a little bit more complicated and requires material we haven't yet discussed. So instead, we're going to kind of look at this through a simpler lens of how to define clone that's going to work with most situations, not everyone, but will allow us to at least look at this through the lens of polymorphism and how that interacts with it. So let's look at the clone method here. Like we said, it has no parameters, and it should return a copy of the calling object. The returned object should have identical data to that of the calling object, but it should normally be a different object. You usually want the clone method to return the same kind of copy of what we have been defining for copy constructors, which is known as a deep copy. A clone method serves very much the same purpose as a copy constructor, but there are situations where a clone method works as you want, whereas a copy constructor does not perform as intended. So when we look and pick apart the clone method, one of the things you have to understand is that same as any other inherited method from the object class, the clone method needs to be overridden before it can perform correctly. The heading for the method clone is as follows: protected object clone. So we don't have to worry about parameters or anything like that. If a class is a copy constructor, you can define the clone method for that class by using the copy constructor to create the copy returned by the clone method. For example, we look at the class sale. The following definition could be added: public sale clone, return new sale this. All right, this of course is specifying the sale here. All right, we're looking at the sale object. We want to return a new instance of it. So when we look at the clone method, this of course using a copy constructor is not the official way to define it. In fact, Java explicitly says you shouldn't do it this way. But because we're still kind of on a rudimentary exploratory level and we haven't really deep dived yet into it, and we'll look at that later, this is just a way for us to kind of get used to looking at it, start getting that idea in our head of how we can use this, especially since we're looking at how polymorphism really plays into this. And while it does work correctly, there are some people who say, yeah, it's acceptable, you could make it work. However, we're going to look at, again, the official chapter or the official method when we look at the clonable interface, because the clonable interface is actually going to implement clone in a much more acceptable manner and actually a much better way for us to handle it in our programming. Now, as we talked about, the clone method does override, all right, because if we look, for example, the example that we gave for the class sale, it has sale as the return type and it's giving public rather than protected access. Remember, the original object class had protected access. Now, despite the changes in the method heading, this definition does override the method clone that was inherited from the class object. And as we noticed previously, a change to a more permissive access, such as public, is always allowed when you're overriding a method definition. And changing the return type from object to sale is also allowed because sale, and every other class for that matter, is a descendant of the class object. Now, the clone method for discount sale class could be defined very similarly. Public discount sale clone, return new discount sale. And there's the this again. Now, we do have some pitfalls to kind of be aware of. For example, the way we're defining things right now is sometimes the clone method return type would be an object. And of course, if we look at object, that's the object class, not necessarily the class base type that we want to have. And this really kind of starts applying, especially if we look at older code. Now, this would be very old code because this is prior to version 5.0. Java is obviously much farther along than this now. But in those older days, Java did not allow covariant return types, and so did not allow any changes whatsoever to the return type of our method. In those earlier versions of Java, the clone method for all classes had object as the return type. And this is because the clone method for a class overrides the clone method for the class object, and the clone method of the class object has a return type of object. So, of course, it can create some dilemma there. Now, if you happen to encounter a clone method for a class that was designed and coded before version 5 of Java, the clone method will have a return type of object. And again, it's just something that you're not going to need to know, but if you ever encounter this, when you are encountering these older versions of Java with these older clone methods, you'll need to use a typecast on the value returned by clone. So, in that older code, let's just say we have a class called oldClass that was defined before Java 5.0. If an original is an object of the class oldClass, then the font would produce a compiler error message, oldClass copy original.clone. The problem is that original.clone returns the value of type object, while the variable copy is of type oldClass. So to correct the situation, we'd have to typecast to follow. OldClass copy equals parentheses oldClass and parentheses original.clone. And of course, that old.class is the typecasting that we're trying to do, the coercion, and to force it into that oldClass type. Now, when we look at newer code, obviously we don't have the same kind of issue because it's a newer version of Java, but we could still encounter this from time to time. It's perfectly legal to use object as a return type for a clone method, even though it's not the preferred return type. And when in doubt, it causes no harm to include the typecast. You're always welcome to put the typecast in there just in case, because again, it's not going to hurt anything. In fact, it just, if anything, Java's like, oh, you explicitly want me to use this. Got it. So for example, if we were to say the following, we say sale copy say equals original sale.clone, you'll notice that this is not going to give us any errors here. We don't have to use the object class here because in the newer versions of Java, it recognizes what we want to use here. However, again, if we put that parentheses in front of it, say explicitly make that a sale object, again, we're not going to get any errors because Java also recognizes how to handle that. Both of these will be treated exactly the same. So if you're like, oh, I forgot the parentheses, or oh, if I put the typecast in here, is it going to affect anything? No, both of these are going to work, and so you don't have to worry about that. However, if you are ever in doubt like of whether or not you should include the typecast, for example, like I don't know the version of this code, maybe you're working with some really old code for some reason, you can always put the typecast on there if you are ever in doubt. Now, another pitfall is there are limitations to copy constructors. Remember, we are basing our current iteration of the clone method on copy constructors, and copy constructors work well in most simple cases. However, there are times when they do not, and they can't do their job. That's why Java favors using the method clone over using a copy constructor. So copy constructors can work great till they don't. Now, again, copying versus cloning has, of course, pros and cons for both sides, right? So here's a simple example where copy constructors does not do its job, but the clone method would. So suppose we have a method with the following heading. All right, it's going to return a saved copy of A, that is, if B is the array returned, then B of I is supposed to be an independent copy of A of I. So if we look here, we are passing in a method that says bad copy. We're passing in our sale array. We have a new sale array B, and we're saying it equal to A.length. Okay, nothing really to worry about there. But they say for int I equals 0, I is less than A.length, I plus plus. B of I is equal to new sale of I. And this is where the problem comes in here, because we're trying to initialize it to this new instance here, right? And of course, then obviously when we're done, we just return B. So those limitations where they start coming into play here is you'll notice if our array contains objects from a derived class of sale. If we look at this last one real quick here, fly back here, boop, boop, boop. Okay, if we look at this, all right, we have a sale object here. So this is a very applicable to what we're using. All right, if it's of type discount sale, then bad copy would not return a true copy of A, because every element of the array bad copy A will be a plain old sale array object. It's not going to be a discount sale. All right, the sale copy constructor produces only sale objects. No element in bad copy A would be an instance of the class discount sale. However, if we were to use instead the method clone, things would work out as we would expect them to. This would be the correct way to define that copy method. So if we look here at the good copy, everything's the same except for in here we have B of I is equal to A of I dot clone. And this is what we want to see. So otherwise, these methods are exactly the same as between them, except this is using .clone. All right, when we look at late binding, because it just keeps coming back to us, right? Late binding or polymorphism is what allows us to do this. So A of I dot clone always means to return the correct version of the clone method. If A of I is an object created with a constructor of the class discount sale, well, A of I dot clone would invoke the definition of a clone given in the definition of discount sale. If A of I is an object, though, created with a constructor of the class sale, well, A of I.clone will invoke the definition of clone given in the definition of the class sale. All right, so going back to clones as copy constructors, because remember, that is kind of the archetype we're kind of use here. We have defined the method clone in terms of copy constructors right now. So for example, for our sale object, public class sale clone, return new sale this. And for our discount sale, we said public class discount sale clone, return new discount sale this. So this is kind of how we're operating our clone methods right now, which is not, like I said, a completely correct approach, but it will work for the moment. So when we examine this, why does the method clone any different necessarily than using a copy constructor? Because they look like they're kind of effectively doing the same thing. Well, the difference is simply that the method creating a copy of an element, A of I, has the same name clone in all the classes, and polymorphism works with method names. The copy constructors named sale and discount sale have different method names, and polymorphism has nothing to do with the methods of different names. All right, as soon as you have a different named method, it's not polymorphism. It's not going to have the same effect because you're not looking and branching from that same method. That's why when we looked at the clone method, it is because it's the same method and same method name that are doing the same thing or similar things within the variations. Now, we will have more to say about the clone method later on when we get to discussing things such as the clonable interface. And just real quick, we're going to pop over to Eclipse here to take a look at our code. And you can see here I have our copying demo. And in here, we are creating a sale array object. It's it's a pretty small size too, so we're just only putting 2 elements in here. And then what I want to do is effectively create this is my bad copy. So this is using copy constructors. And then down here we have our good copy, which is going to use the clone method. All right. Now, if we look down here at how these two methods work, here's our bad copy, just like how we saw with the notes. Here it is. It's not going to work correctly, whereas this one is using the clone method. And if I were to run this, because these are just using sale and discount sale, and you'll see that both of these now have the clone method within inside of them. So I'm going to go ahead and run this. All right, and you can see with copy constructors, we get the total cost 130, 130, and then here we have the total cost 4.5. Here it's 5.0. But if we look at the clone method, we get 4.5 and 4.5, which, if you remember, if these are truly identical, because we are cloning them, or copying them, if you rather, this value right here and this value should be the same. However, as you can see, we do not have the same value. But down here we have 4.5 and 4.5, which means that these values are calculated correctly here with the clone method versus how we would do this with a copy constructor. So very important to note there.